I'd like you all to give a very warm welcome to Mark Bennett.
Thank you, Anita. And good evening. First and foremost, good evening. And thank you for giving up your Thursday evening, or part of your Thursday evening, to come and listen to me talk. A lot of you here, so it's great to see you all, and welcome, welcome. I'll just warn you that the slides have just seemed to be falling out now and then, so hopefully we're not going to have any problems with the screen, but if it does, just please bear with me. Okay, in terms of kicking off, for those of you who don't know me, my name is Mark Bennett, and I am a nutritional therapist, and what that means is that I work in clinical practice with people who have got typically chronic conditions. These are long-term health conditions and I'm using the scientific research base to basically achieve their health goals. I also have these other modalities that I work with as well, so gut and psychology syndrome practitioner, the certified gluten practitioner, and a nutrigenetic counselor. So I use those modalities as well within my clinical practice. I run a clinic near Brinton, just outside Thatcher. Okay, let's kick off and discuss what we're going to cover tonight. We've got an awful lot to cover, a lot of ground to cover. So, summary. What are allergies, sensitivities, and intolerances? These are words that are used interchangeably and are often used in the wrong manner. The immune system and gut health, so I'm going to hopefully try and explain to you why gut health is absolutely essential to the immune system. And of course, sensitivities are an inappropriate immune response to an external agent. The connection between sensitivities and chronic disease. This is the real meat of the presentation. I want you to understand that if you have inappropriate sensitivities, that chronic disease is probably inevitable in some respects. And food sensitivity testing is a minefield. We'll talk about that in much greater depth. Gluten-related disorders, which is something that I'm very passionate about. I'm really interested in gluten-related disorders, so that covers things like celiac disease, non-celiac gluten sensitivity, and wheat allergy. Autoimmunity, which is another area that I work a lot with clients on. The road to health, how can you regain your health based on the information that I'm presenting with you tonight. And then we're going to have a questions and answers session. And then we're going to do the raffle. So the raffle's for these two prizes. There's two food sensitivity testing packages being given away worth £400 each. So that's the testing has been given away by lab, plus my interpretation time, plus blood draw for two people who are here tonight. So let's move on quickly to the basis of what I do and how I do it. And this is based on what we call the functional model of health. Now, the functional model of health is based on the fact that the body consists of 8 key interconnected systems. Digestion, absorption, as you can see, these are the type of systems we're talking about: energy, detoxification, communication, transport, and structural integrity. And the concept here is that I'm looking for why. If somebody's presenting with symptoms, no matter what those symptoms are, why are you presenting with those symptoms? Yes, we can look at it from a sort of symptomatic relief perspective, which is what modern medicine does, and there's nothing wrong with that because lots of people need symptomatic relief. But at the end of the day, what is actually causing the migraines? What's causing the bloating, the digestive disturbances, the joint pain, whatever it is? What's causing the autoimmune condition, which is loss of tolerance? You lose self-tolerance. Basically, the immune system is attacking parts of the body. So the functional model turns it entirely on its head and is looking at why things happen. It's about causation, triggers, what we call mediators or perpetuators of chronic conditions. And everything is connected with everything else. The concept that things in the body exist in isolation is just ridiculous. Things are connected. Everything connects with everything else. What happens in the gut affects virtually every aspect, well, every aspect, I would argue, of the body. So what makes you, you, is unique to you. Biochemical individuality absolutely is the case. One size does not fit all. There are people that I see in my clinic who can't eat broccoli. You know, it does them damage. It actually causes problems. So broccoli is a healthy food. I'm not knocking that for 1 second, but the thing is you cannot say that everybody should eat broccoli, and it depends on the current presentation of that client and how ill they are. So let's actually start off with some definitions here. The words allergy, sensitivity, and intolerance are used all the time. I hear clients say, or people that I'm talking to say, well, I'm allergic to milk. Well, you may be allergic to milk, or you may not be allergic to milk, but the point is there's a big difference between having an allergy and a sensitivity or an intolerance. Now, this is a pretty brief summary of the differences between these terms, but it's really, really important. Because tonight, we're talking about sensitivities. We're not talking about allergies, and we're not talking about intolerances. And allergies and sensitivities are immune system responses. Okay. So as you can see on this particular graphic, the immune system is involved in both allergic and sensitive reactions. Intolerances do not have an immune component. Okay. So a classic intolerance that no doubt everybody in this room would understand is lactose intolerance. That's the sugar in milk. Okay. And that is the inability of the body to break down lactose, the sugar in milk, because you don't have enough lactase. Anything with an A's on the end is an enzyme, and that breaks something down in the body. So you have lactose intolerance. But that is not an immunological response. An allergy is an immunological response, but it's overt and it's obvious. So you probably know people who have allergic responses to things like peanuts or latex or an insect sting. They get an immediate, acute reaction to that particular stimulus, external stimuli. And it is pretty dramatic in some instances. In fact, often it is life-threatening. Anaphylactic-type shocks occur. People have to carry EpiPens in order to be able to deal with that particular situation at that particular point in time. We're not talking about allergies, but it's important that you understand what an allergy is. And what we're talking about is sensitivities, the middle column here. And sensitivities are immune-based, but they're different parts of the immune system. We'll talk about that in a second. But they are delayed. So they're delayed typically anywhere from 2 hours later to 3, even 4 days later. And this is why people get confused with what they eat and what impact what they eat has on their health. Because it's quite logical to say, well, okay, I've just eaten lunch and I've had some chocolate, and I'm not my bloating is getting really bad, or I'm getting abdominal cramping. And it's quite logical to say, well, what have I eaten recently that I haven't eaten for some time? And it happens to be the chocolate. Well, it could be the chocolate, but it could also be the bagel you had 3 days ago. And this is why, with all due respect to individuals, they get confused, and it's very easy to get confused because actually you don't really understand what is causing what. And that's where food elimination programs come in to their own, because actually you use a strategic approach working with a professional practitioner to actually take the key things that typically might cause issues out. But of course, nowadays you can test as well, but the test is only as good as the test, as you'll see in a minute. So hopefully that is reasonably clear as to what is going on between those three different words. So now let's look at the immune system. The immune system is an incredibly complex system. And I don't profess to be an immunologist. But my understanding of the immune system is reasonable. And in essence, what I want you to understand tonight is that there are many, many different aspects to the immune system, many arms to the immune system. And in essence, we have two sides, two distinct sides to the immune system. We have what we call the innate side, which is the first response side. So this is the immediate response. This is like ground troops that are being deployed. They can just be deployed imminently to any crisis that the body has. So these contain things like physical barriers. So these are the skin and the gut lining. There's secretions, some mucus secretions, bile, saliva, those type of things. They're used to defend us. They're first-line defense, okay, against things that aren't going to do us any good. And then there's something called complement. And complement is something we're going to talk about later on. And it's really important you understand what complement is because it's part of the innate first response immune system. On the other side, you have adaptive. Adaptive takes time to respond. It's special. It's like special forces. And this is how vaccines work. So the whole idea is that you basically introduce something, you get an immune response, and then the body holds on to that memory. So when you get it again, you can actually respond quicker to that particular stimuli. But the adaptive immune system is broken down into what we call antibodies or immunoglobulins, and that's what the IG stands for in those little words, those little acronyms. So immunoglobulin A, immunoglobulin D, and these are different parts of the adaptive immune response, okay? And there are different arms, as you can see. So IgE is to do with allergies. So we're not discussing IgE today. So if you go and have a skin prick test, for example, that typically will be an IgE test. It's testing for an allergic response to a range of foods, let's say, or external agents. But that's allergies. That's immediate on the adaptive side. But typically what happens with food sensitivities, we're talking IgG. IgG is tested across all food sensitivity testing involves IgG as a component. And there are 4 subtypes of IgG. And you have IgD, which is a bit of an enigma, but is thought to be to do with viruses and how to protect the body against viral attack. IgA is typically involved much more in autoimmunity, and IgM, which is a first responder. So there's lots of different things going on. So where is the majority of the immune system located in the body? No surprise, but it's the gut. This wonderful system that we all abuse on a daily basis. 25 feet of tubing from entrance to exit. And you will see here, you've got the stomach. And then you've got the small intestine here, where nutrients are absorbed. And then you've got the colon, goes up the right-hand side of the abdomen, under the rib cage, and down towards the exit. This is the liver. So 70% of the immune system is located in the gut. Why? Why is 70% of the immune system located in the gut? Good question. But the reason is because that's the single largest interface that we have with our external environment. The size, the surface area of the small intestine, which it seems a bit ironic, it's called small, is the size of a tennis court if you actually lay it out. And all the little finger-like protrusions that come out of the side of the tube, the villi, they call them, and we'll talk about them later on as well, because that's to do with celiac disease. It's the size of a tennis court. It's huge. And why is it so large? It's large because that's where you absorb your nutrients, and you need a big surface area to absorb lots of different nutrients, all the micronutrients that you get from your food. And it was Hippocrates who said, famously, many moons ago, 2,400 years ago, that all disease is seated in the gut. And we are actually now, the modern science is starting to validate that particular statement. Because I'm hopefully going to get across the point tonight that you cannot be well, optimally well, with a gut that's not working properly. And if you think about it, the average Westerner consumes anywhere between 3 to 7 tons of food in their lifetime. That's a lot of food. A lot of food, and probably most of it isn't actually what I would classify food. It's stuff. Yeah? But anyway, let's call it food, for argument's sake. So it's the single largest interface between us and our environment. So the microflora, now, probably lots of you in this room have heard of the microflora, but for those of you who don't know what the microflora is, these are the bacteria that live in the gut, and we are covered in bacterium. We literally are surrounded in bacteria. Our eyes, nose, lungs, the skin. The gut, though, has a significant population of bacteria. And the microflora represents that population or different populations of bacteria. So in fact, there's a microecosystem going on down there. The average adult has over 2 kilos of bacteria in the gut alone. That's a lot of weight that you're carrying around in your gut. And there are over 100 trillion of these bacteria in the average human gut. That is an enormous number. I tried to work out how big that number was, and I think it's the number of footsteps it takes to walk to Pluto and back 7 times. Sorry, it's a really sad thing to admit to, but anyway, there you go. But it's a huge number, and it dwarfs us. There are lots of different discussions about how many human cells there are, but let's call it 36 trillion. So we are outnumbered 3 to 1. People talk about 10 to 1, but it's probably more like 3 to 1, okay? And it is, therefore, we think we're human. We're not. We're actually bacteria. Well, primarily bacteria. And there's over 1,000 species. I mean, when I was studying, it was 500, and it's gone up to over 1,000 in a few years. So we're constantly finding out more things about what's going on there. 3 million plus genes. This is incredible. When they decoded the human genome, we ended up with sort of like 22,000 genes, which really didn't put us where we wanted to be put in terms of the hierarchy of genetic capability. Yeah, there's lots of other animals that have more genes than us. But what was actually not discussed was the fact that we actually are a symbiotic organism. We work with the bacteria in our gut, and actually the genetic component of the bacteria in the gut is 3 million plus genes. So actually, when you combine our little 22,000 with 3 million, we're a superorganism. And we know through the science that there is horizontal genetic transfer going on. So we're actually transferring genetic material from the bacteria to our cells and vice versa. It's quite extraordinary what's happening down there. And what do the microflora do? Well, they do a lot of things, and the more science I read and the more research papers that come through when I'm not in clinical practice, it's becoming very obvious that the Hippocratean quote is absolutely spot on. All disease is seated in the gut, because actually what they do is just phenomenal. They modulate immune function. This is important. This is very much part of what we're talking about tonight. Inappropriate immune responses to things are sensitivities. So the microflora have to be in balance. Okay, and the microflora need to consist of beneficial bacteria, good bacteria. Bacteria are not all bad. It's not like the Dettol lab where they killed 99.9% of everything dead. Yeah? We need these bacteria. Yes, of course you can have bad bacteria, and you don't need bad bacteria, but also we do need some bad bacteria. So the balance of the gut actually has some viruses and pathogenic organisms in it, but it's in balance. Okay. It's about balance. Everything's about balance when it comes to the body. But what do? They're involved in digestion, getting more nutrients from the food, immune modulation, making sure your immune system doesn't over-respond to something. Vitamin synthesis. We actually make vitamins in the gut. You know, B vitamins and vitamin K can actually be manufactured in the gut. Detoxification, really important for eliminating toxins from the body. In this toxic world that we live in, we have 85,000 chemicals being released into the environment since the end of the Second World War. We're literally being marinated in it. Weight control. We know if you take stool from a genetically programmed, the other way around, from a wild-type mouse, which is lean, and you put it into a genetically programmed obese mouse, then what happens to the obese mouse is they actually start losing weight. It's quite incredible. We know that a lot of chronic conditions are based on imbalances in the bacterial species. So what happens when it goes wrong? What we just talked about is something called orthobiosis, which is balance. And what we're talking about now is a term called dysbiosis. And dysbiosis is the imbalance in the microflora. So your microecology of the gut is suddenly imbalanced. So you have less beneficial bacteria, you have more pathogenic bacteria, you have an overgrowth of yeasts and fungi, and you start having problems. And this can actually cause systemic issues. What we know is that with dysbiosis, you lose what we call oral tolerance. Oral tolerance is the ability to not respond to inappropriate material or appropriate material, it might be appropriate foods, introduced into the body, and the immune system actually leaves it alone. So it says, do you know what? That's a dairy protein, let it go. That's a bit of dog hair, let it go. That's grass pollen, let it go. And of course, when we have sensitivities to something, an immune response, the body is inappropriately responding on an immunological basis to that particular antigen. But we know that dysbiosis, the bacteria in the gut, everything I talked about in terms of the balance of those microbes, okay, is absolutely fundamental, totally fundamental to how you tolerate your environment. So dysbiosis, imbalance, causes problems or lack of oral tolerance. So what causes dysbiosis? How you were born. C-sections. We know that those who are born through C-section are more likely to have or be on the back foot when it comes to the balance of their microflora. It's not saying that everybody who's born through C-section has a problem, but we know for sure that people who are born through C-section are more likely to have, for example, eczema or hay fever later on in life. Diet. What you eat is really important. We need to feed these bacteria with fiber. And we're not eating enough fiber in our diet. The deal is they can't go hunting for food, but we can, and we eat foods that have fiber, so fruit and vegetables. I'm not talking about all bran here. Fruits and vegetables, please. And the deal is we supply these bacteria with the fiber, and they kick out, they metabolize the fiber, it's their food, and they metabolize it, and they kick out these incredible byproducts. And these byproducts are anti-inflammatory and all the other things we've talked about. And they are absorbed systemically through the body, and they do wonderful things. So fiber is really, really, really key to the diet. Not a KFC. Antibiotics. We've used antibiotics now for best part of 70 years, 60, 70 years. And I'm not saying antibiotics are bad. I mean, they've saved a lot of lives. But we are overdoing it, and we're using them too frequently, and not for life-threatening situations. And of course, for life-threatening situations, they are essential because they will save your life. But lots of people are asking for antibiotics when they don't need antibiotics. And we're actually now, the powers that be, in terms of our health system, are actually suggesting we're now in a post-antibiotic era. This is actually quite problematic. And a lot of antibiotics are put into the food supply. Over 50% of total antibiotic production is used in our food supply. That's one reason to choose organic. Toxins and pollution. We've talked about it. We're marinated in 85,000 chemicals since the end of the Second World War. Only a couple of hundred have ever been tested on human health. It's not the way it works. You don't have to test these things before you release them into the environment. You just release them to the environment, and there's a problem. Look at DDT in the 70s. It takes time for these things to become a problem, and then eventually they might be taken out of action or maybe supplied to the third world because they don't complain about things as much. Medications. I'm not saying medications are bad. Medications, of course, are an essential part of healthcare. But medications decimate the microflora, the balance in the bacterial species, and they can cause trouble down there. So the more medications you take, the likelihood is that you end up with poor gut health. Infectious diseases, yeah, they cause havoc. Salmonella poisoning is a classic one, where if you end up, God forbid, developing salmonella poisoning, then of course the impact on the microflora can be significant. Chronic stress. Stress is, the modern world is stressful. You know, jobs, wives, partners, husbands, financial stress, whatever. It's just we're doing more. We've got digital stress, Facebook stress everywhere. And the body doesn't understand the difference between chronic stress and acute stress. So long-term stress, the body just doesn't get. Stress is an innately intelligent response to an external crisis. But if it goes on and on and on, we know it shuts down the digestive system. It shuts it down. Why would you eat a 4-course meal when you're running away from a tiger? You're not going to do that. So what does the body do? It's intelligent. It shuts these things down. So the majority of these are modern things. The majority of what I've got on that particular graphic are modern. The type of birth, you didn't have an option. Diet, you used to eat genetically congruent foods. Antibiotics are recent. Toxins, pollution are recent. Medications are recent. Chronic stress is recent. No wonder the majority of the population have got dysbiosis. So, is everybody with me so far? Okay, so what does dysbiosis lead to? Well, as I said, loss of oral tolerance, or the ability to handle external stimuli and have an inappropriate immune response to something. So it gives us loss of oral tolerance, as I said, and that leads to inflammation. Now, this is really, really key. because inflammation is recognized by modern medicine as being absolutely fundamental to all chronic disease. So anything that goes on and on and on will be perpetuated by runaway inflammation. And this is, again, the whole point of this evening. It's about, well, where is that inflammation coming from? It might be coming from the food you're eating. It might be coming from what you're doing to your gut. It might be coming from a trigger that you're inhaling. So it could be anything. It could be benzene that's coming out of car exhaust. It could be a preservative in a makeup. It could be, honestly, it could be anything. We'll talk about that later on. But basically, when we talk about food, inflammation in the gut losing oral tolerance leads to inflammation and is the basis of all chronic long-term health conditions, which, by the way, 1 in 4 adults in the UK present with right now. So, if there's one slide I want you to take away in your mind tonight, it's this one. Sensitivities cause chronic inflammation, which causes chronic disease. If that's the only thing you remember tonight, I've done my job. Because that is absolutely fundamental to what we're talking about this evening. And the potential impact of this on health is all these symptoms and potential conditions. And believe you me, there's more, but these are the sort of common ones that I see in clinical practice. And these probably resonate with a number of you in here tonight. I'd be very surprised if there's no one in here tonight that's got one of these, or 1 or 2 of these going on. So summary so far, just so we're clear. Sensitivities are immune reactions. 70% of the body's immune system is located in the gut. The balance of the gut bacteria is fundamental to oral tolerance, so you don't want to lose the ability to not respond to something that is, quite frankly, harmless. And loss of oral tolerance can cause sensitivities, and sensitivities equals inflammation, because the immune system is over-responding to an external trigger. And of course, if it's over-responding, that's inflammation. That's what inflammation is. So, at the risk of being boring, sensitivities cause chronic inflammation, which can cause chronic disease. I think you've got that by now. So far, so good? So, what can we do about this? And also, what is going on when you eat?